All right, today's instructional objective, students will be able to identify sedimentary rocks and their properties. Please take a moment, read the passage to the right, and answer the following question. How are sedimentary rocks formed? Responded with, they're formed by weathering, erosion, deposition, and cementation. Sedimentary rocks are formed when sediment is deposited by water and wind. Most are formed through erosion, weathering, deposition. Right? They're formed when sediment is deposited by water and wind. Remember deposit, like you're dropping money off at the bank, you're making a deposit, or you could drop off sediment in a riverbed or in a riverbank. Get it? Sedimentary rock are formed by weather, erosion, deposition, compaction, cementation. Sedimentary rocks are formed by pieces. So I think what Emily's referring to there is the clastic nature of some rocks. Clasts mean broken up bits or broken up pieces, and those sometimes get glued together, whether you're making it into breccia with angular fragments or conglomerate with rounded ones. And much more of the same. Very good. So let's move on. Okay, so which sedimentary rock is this? Everyone should be in the Pear Deck. Hint, hint, hint. Yes, you want to have your reference table out, whether digitally or the physical one that we wrote all over. But there's a big hint on this one. If you take a look at it, you can see the outline of what appears to be a scallop or some kind of seashell. Well, I'm proud nobody said conglomerate, right? Because conglomerate's got those big rounded chunks. The answer is limestone. So if we, by the way, I'm sharing my screen in case you want to follow along. If you notice here for limestone, it says crystalline or bioclastic. Bio, like Miss G referenced, means life. And you can see things like cemented shell fragments. Now that's not really a shell fragment. It's more of an imprint of a seashell. But still the same. That's limestone. The other thing you want to notice about limestone is it's generally white in appearance, and if it's not white, it's going to be a gray or maybe like a light beige color. Color is actually a pretty good indicator. All right, cool. Next. Can I click next? There we go. Which sedimentary rock is this? So there are a lot of pretty decent clues on this one. You can see those layers. So the darker brown layers and the lighter beige, lighter tan layers. What about particle size? Call it out if you think you know. Man, it's so hard to tell particle size on an image like this. But I know it's not pebbles. No, it's not cobbles. Also know it's probably not shale, because shale has got that baby powder smooth appearance. And pretty much everyone's right on this one. We're looking at sandstone. Yeah. So bitumen is called, generally speaking, well, whoever just changed it. Bitumen is called, generally speaking, is black. So if it's not black, that'll immediately give it away. And conglomerate, we know there's no pebbles. Yeah. We're missing some people from the chat. I currently only have 10 people in the chat, and we have 16 students in the room. So if you're one of those 6 people that are not in, please join us. I'm dropping another copy to the link. Man, this one looks like my wife's cooking. Just kidding. Only 10 responses. Let's take a look at what this monstrosity is. All right, so interesting. We got a bunch of people saying conglomerate and a few saying breccia. So let's just jump back to the image. You can see some really sharp angles on a bunch of these. Sharp angles. And we're going to go to ESRT page 7. And if you look through here for breccia, breccia contains angular fragments. So if you were one of the few that said conglomerate, I got bad news. You were wrong. This one. I'd say this one looks kind of unusual. Not like other ones that we've seen before. Only 4 responses. Well, Miss G, what don't we see in this specimen? No fragments. Okay. So get rid of clastic. Do we see any evidence of prior life? So I guess we can get rid of bioclastic. No, it's not coal, because coal is black. All right, and everyone got it. This one's rock salt. So the deal is with this, and these crystalline ones can be very tricky. Basically, you're going to put down crystalline if it can't be anything else. All right? What you're looking at here is that Himalayan pink sea salt. I don't know why everyone thinks that's so special. It tastes just like regular salt. Hold on, is that a rock or is that like a piece of a tree? We can go back to what we were saying before. Do we see clasts? Do I see fragments? It's tough to say. I'm going to guess and say no. I'm not seeing pebbles. I don't see sand. What about bioclastic origin? Do we see life? Yeah. So let's go back to the last one. The last one we said was rock salt, and it didn't really fall into any categories. We didn't see any clasts, no fragments. We didn't see any life, no fossils. It wasn't black, so it's not coal. So let's take a look at what people were thinking. Many people said dolostone. Some people said limestone. And to be honest with you, I could see this being limestone. I could. But this one is dolostone. Very similar in composition. Now, one thing that you could do to tell the difference between the two is splash a little bit of hydrochloric acid on it. You know, like we always have around. So if you throw a little bit of acid on it, you'll see it bubble up if it's limestone, because limestone contains the element, the compound, calcite. Let's go to here. You can see here limestone. Limestone contains calcite. And if we go all the way to the last page in our Earth Science reference table, we find calcite, CaCO3. That's what your bones are made up of. You can see how it says bubbles with acid. So if it was limestone, it would bubble with acid, but I do have bad news for you. It does not bubble with acid, so our answer is dolostone. Good work. We have a couple choices here. It's either clastic or chemical. I hope this isn't just mob mentality. You see everyone putting down clastic. Everyone's like, oh yeah, it's clastic. Yes, that sounds good. And yes, the answer is clastic. And if you didn't know, it's quite simple. All you do is go to ESRT page 7. Almost said 6. Page 7. And you just look right here. Clastic. The word for plastic is metal. Easy peasy. Which rock is made up of angular fragments held together by a natural cement? Now this one's quite interesting. You could answer this one just based on looking at the answers alone. We got scoria, granite, and breccia. Breccia is really the only sedimentary rock on this chart. If you look for scoria or granite, yeah, you'll be on page 6 looking at igneous rocks. Yeah, so that kind of gave it away. Okay, so right now you have a slider, and you can drag that slider up and down. You can put it wherever you want. I'm going to ask you a few questions. We're going to start off with one that's relatively simple. I would like you to highlight the rock sample where you would find it mostly made of particles that are 0.1 centimeter in diameter. So who's made out of rocks that are 0.1 centimeters in diameter? Drag your slider to the correct spot. We're looking for 0.1 centimeters diameter. So that means, right, we're looking at grain size. We're going to be under clastic because clastic is sorted by the specific sizes. So where does 0.1 fall? All right, half of you guys got it right, half of you got it wrong, and 2 people are off the page. The answer would be sand. Because you'll notice here we start off small and we go to large on the right. So 0.006 is less than 0.1, and 0.2 is greater than 0.1. So in this case, the answer would have to be sandstone. Yeah, and everyone's moving to the correct spot. Miss G, you want to make one up? Come on, Miss G, that was easy. Okay, here's another one. This one's primarily used for the walls of your home. This one's primarily used for drywall in your home. Oh, look at that. Everyone's all over the place. So you're going to want to take a look at the chart, page 7, and you're going to want to see the composition. Because it doesn't say anything about drywall, right? It doesn't. It doesn't say anything about building materials. So what you want to do is look at some of the ones that are commonly used. So composition, this doesn't help us because we got feldspar, clay. These things are not used as building materials. We know halite is a food substance. We know that's salt. So we eat that. So that we're not using for our homes. Gypsum, dolomite, and calcite. Those really are the ones that we do use as building materials. Now, if you didn't remember that, you can easily go to ESRT back page and just look through here. Find one that is used for the walls for your house. Oh, I see construction materials, but that's biotite mica. That wasn't a choice. Calcite, cement, but most people don't have walls made out of cement. Drywall, selenite gypsum, plaster of Paris. So gypsum, let's go back to page 7. All right, so it would be rock gypsum. That was kind of a tough one. Yeah, very good, guys, very good. All right, and this is just, I'm going to leave this up for a moment so you could assess how this lesson went after today's lesson. How well do you feel like you understand sedimentary rocks using ESRT page 7. I'm going to ask you to, after you fill that out, I'm going to ask you to go back to our Google Classroom. You're going to notice I posted a few things. We do have our notes from today, so you can go back over that. I did record this session. It will be posted in a few moments. We do have a quiz tomorrow, 15 questions. It's going to be multiple choice for the most part. You're going to be identifying based on pictures. And today you're going to spend the rest of the time completing work on Lab 14. This is a great way to study for tomorrow's quiz. I know it's due tomorrow. Try to get it wrapped up tonight.